Okay, let's take a look at number 2. We're again going to take this parabolic region and we're going to rotate it. But this time we want to rotate it along the line x equals minus 5. That's a vertical line going through minus 5 right there. So we're going to take this parabolic region and we're going to rotate it around the line x equals minus 5. If we wanted to do shells, if we wanted to do disks like the previous problem, we need to make the radius perpendicular to our axis of rotation. We can't do that. It's going to be too much of a pain. The functions that we're going to need to deal with are going to be a problem. So instead, we're going to use shells. We can use shells when the strip, the radius, or the kind of sample piece that we're going to look at is parallel to our axis of rotation. We need to know a couple things. We need to know the radius of each of those shells, how far away each of those little pieces would be from the center. The center is here at x equals minus 5. We also need to know the height of each of those shells. The thickness, in this case, is going to be dx. We're going to integrate with respect to x from minus 5 to 5. So let's start with the radius. This spot right here, it's about x equals 3. So we're about 8 units away from the center. Okay, if we're sitting here at minus 1, if that's our x value, okay, now we're about 4 units away from the center. We need to be able to generalize that for any of our x's between minus 5 and 5. So basically what we're doing is we're starting at any old x value and we're kind of walking over to minus 5. So the radius is going to be x minus a minus 5 or x plus 5. That's going to be the radius for each value of x. The height is going to be, or the altitude is going to be given by the function, which in this case is 25 minus x squared. So if we set this up using cylindrical shells, our kind of quick acronym was 2 pi rat. We're integrating it between a and b, which in this case is minus 5 to 5. The radius has been replaced with x plus 5. The thickness is dx. And the altitude is sitting right there in the middle, 25 minus x squared. That's the height of the function. Now we just have some cleaning up to do. It's really pretty a straightforward integral. Pull the 2 pi out and expand using FOIL or asking your calculator to kind of expand that polynomial for you. You see we've got minus x cubed minus 5x squared plus 25x plus 125. Again, antiderivative is just straightforward polynomial rules. Each of those exponents is getting increased by 1. We're dividing by the new exponent. So we've got minus x to the 4th over 4 minus 5x cubed over 3 plus 25x squared over 2 and plus 125x. We're going to use the fundamental theorem of calculus. We're going to evaluate that function at 5 and at minus 5 and subtract the difference. When we do that, we get 2 pi times these nasty looking fractions. If you clean that up, you're going to end up with 5,000 pi over 3. So if we take that parabolic region and we rotate it around the line x equals minus 5, that's what we're left with, 5,000 pi over 3 as the volume.